Welcome to our study site on the traditional territory of the Kwani First Nation. We're here doing a heat injection test in a well drilled by the Yukon Geological Survey in October 2022. This well is 220 meters deep and is part of a larger project that involves assessing the geothermal potential around southwestern Yukon. Once we have our temperature profile, we can start our heat injection. The heat injection test is designed to let us measure the thermal properties of the different lithologies that this well passes through. We'll be injecting heat for 2 days, and then we'll follow the recovery process for the following 4 to 5 days as the well recalibrates and the rock come back to their standard temperature. This setup uses fiber optic cables to measure temperature throughout the well. In the junction box, they're paired with a copper wire through which the heat is injected. This black cable contains the fiber optic cables and the copper wire and is lowered 200 meters down towards the bottom of the well. This structure lets us lower the cable and keep it steady throughout the experiment, including the heat injection and the recovery process. Let's go see what the cables are actually hooked up to inside the trailer. In here, there are 3 main components. Let's start with the heating component. This is our heat pulse, and it's what injects the energy into the copper cable down the well. It's connected outside to a generator, which is 480 volts and up to 20 kilowatts. That generator, combined with this heat pulse, lets us inject roughly 28 watts per meter all the way down our well, heating the water and the surrounding rock equally for the whole 2 days of injection. Down here, we have the fiber optic component. So this black box is a digital temperature sensor, and it sends a laser down the blue fiber optic cable and into the well. And the response is what allows us to measure temperature at 25 centimeter intervals throughout the whole fiber cable. This measurement is taken at each of these points every 3 minutes for the whole duration of the test. That means it starts before we start injecting heat for our initial profile. It continues to record temperature for the 2 days of heat injection, and then it keeps going for the last 4 to 5 days, measuring the recovery as the ground comes back to equilibrium. Now, the fiber optic cable is great, but it's not perfect, so it goes through a calibration bath, and that's what we're going to look at next. So let's open up the calibration bath and see how that works. So the calibration bath is kept at a constant temperature using an aquarium heat pump and a bubbler. The bubbler makes sure that the temperature is constant throughout, so there's no stratification as different areas warm. Our fiber optic cable is wrapped around and tied to the bottom to make sure that everything is as close to our thermistor, which is what we'll use to calibrate post measurements. So these are all the components of our heat injection test. In summary, we inject heat for 2 days and we watch the recovery process over a 5-day period. How the rocks respond to the injection and the recovery lets us estimate the thermal conductivity, which is essential to have a good estimation